All right, welcome back, guys. So in this part, we're going to be going over some examples of triangle congruence and applying some of those shortcuts. We're not going to be writing formal two-column proofs at this moment, but that's coming. We will also practice that idea. We're really just going to be trying to take some given information, some other inferences we can make from the diagram or from the given information to try to decide how we might state that some of these triangles in the picture are congruent. So let's go ahead and start with this one. We have some given information. We know that D is the midpoint of AB. So this point right here is exactly in the middle of this segment AB, right? Extrapolating from that, we would know that AD, this segment here, would be congruent to BD or DB, however you want to call it. Because D is exactly in the middle, these two parts would be equal. Easy enough. And then we have the second piece of given information here. We have that CD, this line segment here, is perpendicular to, that's what that symbol means, perpendicular. So it forms right angles with AB. So we know that these angles right in here are both right angles. So since they're both right angles, I'm going to use some numbers here. These two angles would be congruent. Angle 1 and angle 2, both measuring 90 degrees, would be congruent. This is not quite enough yet in order for us to say that these two triangles here are congruent. So this triangle here on the left and this triangle here on the right, we don't quite know that they're congruent yet, but we're very close. We also need to keep a lookout for any shared sides or any vertical angles or perhaps some other things that we'll talk about later. In this case, we have a nice shared side right here in the middle. CD is common to both triangles. So this gives us enough information now to know that these triangles are congruent to one another. We have some sides that are congruent. We have some angles that are congruent. And we have another side pair that's congruent as well. So we have side, angle, side. Again, it's really important to know that this angle is the included angle. It's the angle that touches the two congruent side pairs, right? And it does in both triangles. So this is SAS triangle congruence. Finally, the last thing we're asked is to write a congruent statement for these two triangles. So remember, when you are writing a triangle congruence statement, you can name the triangles in any way you want, but once you choose a name for one triangle, you have to make sure that the second one is named in a corresponding manner. So let's go through that. Let's say we want to name this first triangle here on the left. Doesn't really matter. Let's call it ACD. ACD. Now, because we've settled on that naming for the first triangle, we need to be careful and make sure we match up the corresponding parts to name the second one. So A, this angle at A, would correspond with this angle over here at B. So that needs to be the first letter for this triangle. This angle up here, C, would correspond with the other angle that happens at this vertex C as well in the other triangle. So C is the second letter. And then D, D also corresponds with D. So BCD is the appropriate naming for this second triangle. This isn't the only way to name it. You can often name these triangles in many different ways. Just be careful and make sure they match up correspondingly. In this case, and in some cases, but not always, the letters that are the same do actually correspond with one another, right? The angle at C and the angle at C are corresponding congruent parts. That's not always going to be the case, and I'll try to make sure to point that out when it happens. All right, let's go to move forward. We're going to do a couple more examples of this. Forgot about this. I'm going to outline this a little bit. It's very faint to see this, so let me do this really quick. And I think you can see these triangles materializing, and this is letter E in the middle there, and D here. It's here. Okay, so there we go. We have these two triangles. We are given a little bit of information here. Feel free to pause the video at any point and try this on your own. Our goal is, again, to decide how are these triangles congruent, what shortcut can we use, and to write a congruent statement. So if you want to pause at any point as we're working through these, feel free to do so. I'm just going to be kind of moving forward. All right, given information, we know that AC is parallel to DB. So those are parallel markings, those little arrows like that. And we also know that those segments are also congruent to one another. So we'll make some congruent markings. Just because things are parallel doesn't mean they're necessarily congruent. So we need separate markings for those things. All right, parallel lines is kind of setting off alarm bells in my head, but we'll come back to that in a minute because I see one really important thing to always make note of. some vertical angles, right? Right here and right here, these two angles would be considered vertical angles. They are created by these two intersecting lines, AB and CD. So these would be considered vertical and they're congruent. That's what the vertical angles theorem says. Okay, so we have some congruent angles and we have some congruent sides. We just need some more information. There's not quite enough yet. So I want to go back to these parallel lines. So we have some parallel lines here and here. Anytime you have parallel lines, you should be considering, do I have corresponding angles or alternate interior angles or anything like that? And in this case, we have two pairs of alternate interior angles. Angle A and angle B are alternate interior angles. They are inside of these two parallel lines, and they are on different sides of the transversal line that connects them, right? They're on kind of the upper part of this and then kind of the lower part, right? So they're on different sides, alternate sides. So making them alternate interior angles. So they'd be congruent. Similarly, we don't need to know, we do have enough right now to use AAS, angle, angle, side, side not included. So we could use AAS. But we do know a little bit more, so I'll go ahead and talk about it. We do also know that angle C and angle D, just like A and B, these are alternate interior angles as well, because right here, parallel lines, okay, and they are on different sides of this transversal CD. So they are also alternate interior. That gives us the additional ability to now also use angle side angle, angle side angle. So we can actually use either of these for this particular problem. Both of them will apply. And then let's go ahead and finish this off with a congruent statement. So triangle, let's call it ACE. So that's the one on the left-hand side here. And that's going to be congruent to triangle. Okay, so A corresponds with B, C corresponds with D, and then E corresponds with E as well. So there we go. Again, we could name this in a couple different ways. If you chose a different naming for your first triangle, then obviously your second naming would also be different. All right. Moving on to question C. Again, feel free to pause the video at any point and try this, but I'm going to keep moving forward. Okay, so here's our triangles. Actually, we have several triangles here, so we'll have to figure out what triangles we maybe can figure out are congruent. So our given information says that AE and BC, these two lines, bisect each other. Bisect means to cut exactly into two congruent parts. So that means that this bigger line here, AD and DE, those would be congruent because it's being cut in half. And also, these two parts are also congruent because they bisect each other. They cut each other in half. Oftentimes, we'll be told that one segment bisects another, and so we can only talk about one of these being cut in half. So in this case, they're bisecting each other. Anyway, so we have some side congruences here. And finally, we also have vertical angles. So I'm going to make use of that as well. These two right here are vertical angles. All right. So with this given information, it's become apparent to me that the two triangles we should be examining are this one right here. I'll kind of color that in. And this other one, we will make it blue, that we should show that these two triangles here are congruent. I think we have enough information to do so. So we'll go ahead and try to do that. There we go. So those are the two triangles we're looking at. We may have information to be able to show others that are congruent as well, but for right now, this is the ones we're looking at. And we have side angle side congruence, right? So we have two congruent side pairs here and here and here and here. And then the angles in between those sides are also congruent. So this is SAS. Finally, let's go ahead and write a triangle congruence statement. Again, at any point, feel free to pause and do it yourself or think about it yourself. Let's pick a naming here. Let's go with BAD because this triangle is bad. Just like that joke. All right. BAD. So B corresponds with C in this other triangle. It's in the same position. A corresponds with E. And D both correspond with one another. So CED. Again, depending on the naming of the first one, you know, they'll both change. Let's keep moving forward. And these will be the last two here. Again, at any point, feel free to pause. So here we have two right triangles. So let's keep in mind hypotenuse leg could be in play. Anytime we have right triangles, we could use that. Only when we have right triangles. Let's see. EF is congruent to GH. So those are congruent. And we also have a shared side in the middle. Remember shared sides, right? Make sure we keep in mind of that. And we have enough. We've already got enough here. This one is actually pretty fast. The hypotenuses, hypoteni, not quite sure there. The sides across from the right angle, they are congruent. And the legs, EH is a leg, HG is a leg. We can use hypotenuse leg. Let's come up with a triangle congruence statement. Again, pick a name for your first one. I'll go EFG. This one, got to be a little careful. Parts that use the same letter may not correspond. Let's look at that now. So EFG. So E, this angle up here in this triangle, is going to correspond with G in the other triangle. So E is going to correspond with G. F is our right angle. It's going to correspond with the right angle over here, which is H. And E, this angle down here, or right there, is going to correspond with this angle here. Well, because they're congruent to one another. So corresponds with E in the other triangle. So this one's a little tricky, right? Notice how E corresponds with G, not with itself. F corresponds to H, and G corresponds with E. So some of these letters do not correspond with the same lettered vertex in the other triangle. It's a little tricky, got to be careful with those things. All right, and our last one, let's go ahead and mark this one up quickly. This one is pretty easy, I think. PQ is congruent to SR. PS is congruent to QR. And hopefully you're seeing it, you're shouting it out right now. They have a shared side. This is SSS congruence, right? So all three sides of one triangle are congruent to three sides of the other. So there we go. And finally, congruence statement. Name it however you want. I'm going to go PQS. And I could pick other namings for this, but this is the one I'm going with. So this is one, when you don't have any congruent angles, sometimes it's helpful to actually use the sides. So PQS is the single mark side into the triple mark side. So I want to name this other one as well. Single mark into the triple mark. So RSQ. Sometimes it can be tricky when you only know sides. I like a mixture, it makes it a little easier. But anyway, that's it. And I'll see you in later parts.